So good morning all. Today we will discuss the seventh topic, that is pressure sensor. So to measure a pressure, which is almost same as in the case of force, because pressure equal to force by area. So indirectly we can measure the pressure by calculating or measuring force. So we can use the same sensor for the pressure sensor. So let us discuss one by one. So as we know, pressure equal to F by A, that is force by A. So we are calculating or we are measuring force by using any kind of sensor. Then from this force we can calculate pressure. So sensing method, to calculate force or pressure we have two options. Mainly we are using two options. One is strain gauge, then second one is piezoelectric method. So these two are the common method for sensing the pressure or force. So let us discuss first, that is strain gauge. So here we are measuring the resistance, changing resistance. From changing resistance we can calculate the strain. The principle of this sensor is that elongation of a conductor increases its resistance. When a force or pressure applies, its resistance will be changed. That changing resistance, that is delta R, that is proportional to the strain. So a typical resistance for a strain gauge are 50 to 100 ohms. Say very little resistance. Its resistance will change, depends upon the force or pressure. Then we can calculate using a Wheatstone bridge, that is the common method. Then when its resistance increase, so as we know, resistance will increase due to, there are two options, either increasing the length of conductor, because rho L by A, so it is proportional to L, so increasing the length of conductor. Then second option is decreasing the area of conductor. There are two options, that is increasing the length of conductor, then decreasing the area of the conductor. These are the two option for increasing the resistance. Then strain gauges are made of electrical conductors, usually wire or foil, etched on a base material. We are using wire or foil which is etched on a base material, that we are going to use as a strain gauge. So it has two ends, that is we can measure resistance from these two ends, and this strain gauge or this sensor will glued on the surface where the strains are to be measured. So it is attached to the surface. It's a contact type method, contact type sensor. Then when there is a change in force or pressure, the resistance will be changed. Then this resistance can be measured using Wheatstone bridge circuit. That is, a Wheatstone bridge circuit contain four resistance R1 to R4. One will be the unknown resistance, that is strain resistance. By we can easily calculate the unknown resistance from this method. Then amplifying it, we can calculate the actual strain. So this is the very basic step. So strain gauges are very common method to calculate force or pressure. Then it's we are calculating its changing resistance. That is up to the strain gauge. So next one is piezoelectric sensor. It's also a common sensor. So now let us discuss what is a piezoelectric effect. A piezoelectric material exhibits a phenomenon known as the piezoelectric effect. So this effect states that when asymmetrical elastic crystals are deformed by a force, an electric potential will be developed within distorted crystal lattice. And this effect is reversible also. That is, first we discussed when a force is applied, one potential will be generated. Now we will discuss the reversible effect. that we are not considering calculating the force, but you should know the effect. That is, if a potential is applied between the surface of the crystal, it will change its physical dimension. So these are the two properties. We will use the first property, that is, when the force is applied on the piezoelectric material, it will generate a electric potential, and the electric potential will be proportional to the force. From this we can calculate the pressure. The magnitude and polarity of the induced charges are proportional to the magnitude and direction of the applied force. From this property we can calculate force and pressure. Then the materials. The piezoelectric materials are quartz, tourmaline, rochelle-art and others. And using this sensor, this sensor can be used to measure the instantaneous change in force, that is dynamic force. So we have discussed two types of sensor. First one is strain gauge, the second one is piezoelectric material, piezoelectric sensor. These two are commonly used to measure the force. From this force we can calculate pressure also. All these methods are example for the contact type sensor. So thank you.